Hey everybody, Iceman50 here. Another late night assembly video. This is on the, today we're gonna finish up the DSO oscilloscope, the little guy we've been working on here. And let's get to it. One thing I wanted to tell you guys is that I just got a promotion at work. So I am now a technical specialist at work, and yeah, that's good. So I'm excited about that. We got a lot of stuff going on there. It's gonna be pretty busy. So okay, yeah, so we don't need this one. We gotta go to step 3, which is, remember we did, it was over here, is the rotary encoder. We finished the rotary encoder, and we gotta get to assembling this in this piece. And all right, let's get into it here. Just trying to catch back up from where we left off. Okay, so mount the small PCB. Please pay attention to the orientation of the PCB. Use the side with outline marking. Okay, so a simple front module, that's what we're at now. Yeah, so I can move you guys down here. Alright. I'll tell you what, we'll move you up a little bit and then we'll zoom you in. Okay, no, I'm way down. Okay. Alright, so remember, we did the whole analog board before. That's all finished. I did get some soldering iron tips, some nicer soldering iron tips for my Heiko. That's like a nice real pointy curved tip. So that's good. And then fit LCD. Let's see so you can see it. Fit LCD to front panel as shown. Yeah, so we got to find the front panel, which is here. Okay. And then it shows it like this. And this. Okay. I'm just going to pull this off. I know I said I'd leave it on there, but there is also, the one reason I didn't see it the last time, the one reason to take this off is that, if you can see here, I'll put it on a piece of white. See, there's something right in the middle of the screen on the clear wrap, so I'm not gonna use it. All right, let's flip this thing over. Flip the main board over while keeping LCD in place. Mount rotary encoder board to the front plate with screws and solder the board to J2. So, what am I trying to like? So they want you to, oh yeah, they just want you to get it on here and then they're saying to flip it over like this, right? Okay. And then they want you to mount the rotary encoder like this. So they want you to put it through remember, it's got the little, yeah, see, like that. Okay. Mount the board, front plate with screws, and then solder the board to J2, the main board. Okay. So, I'm assuming we got our little bag of screws here. Okay. Oh, why don't we get out I haven't been using this enough. Let me zoom you out here. I got one of these iFixit Mantis kits or whatever. This is like the complete kit. It's got a magnetic. Let's see, there's lots of. It's got magnets in here to hold it all together, and then we got the big driver, this nice one, and we got this little teeny. These are really nice screwdrivers. This is a really nice set. So J0 Phillips. Let's see. These are great. Watch this. I think it's these two short screws. They don't really say, but there's. Oh, hey, and it is magnetic, which is pretty cool. Okay, so we're gonna. Interesting. It says, important, make sure PCB evenly touches the front plate while doing C. Oh, yeah, so they want you to just make sure that... Okay, so what I did read is that... Let's see. I was going to say what I did read was putting the rest of it together, but... I'm looking at this and I'm not entirely liking it. I don't know why it's not sitting down more flush. Let's see. Yeah, look. I know you can't quite see in there, but the 9-volt battery isn't not 9-volt battery. The plug isn't in the right place. It's way out of place here. So somebody screwed something up somewhere, and I don't know. Let's see. Yeah, if you line up that hole, the switch doesn't line up. One of these two things is no good. All right, everybody, let me figure out what the issue is, and I'll come right back. If you look at this. Get it to where you guys can see it. If you look over here, I realized I put the switch on the wrong side. So we got to put it on the top side. That's why it's not lining up. That's why everything's all wonky and weird. So let me pull out this switch right here, and we'll keep going. I do have some solder wick. This stuff is just like a copper braid. It's like wire, and it just wicks up the solder. What you do need with that is, let's see, so liquid flux, ship quick. Nice and sticky. Question is, will this dispense? And the answer is, oh, yeah, I guess a little bit. Yeah, that is coming out. Okay, so we're just gonna squirt some flux all over it. And then we're gonna come in here and we'll heat this up, and yeah, let's do it. Let's do it to it. All right, it's all over but the crying at this point. So let's carefully. These are approved electronic approved pry bar here. Very carefully. All the solder pads look good. Yeah. That's the back side where I was working. So you can see this side, it looks fine. There's nothing wrong, nothing happened. So we're gonna go ahead and get some alcohol. And we're going to clean this up. Let me get a Q-tip. Hang on, I'll be right back. Here's the alcohol, 99%. Boom! Alright, so let's get a little of this. It looks like we're gonna have to clean the LCD too, because this flux gets all over your fingers and everything. Just so you guys know, it gets everywhere. Mmm, yummy. So, do that all right. Put our approved electronic tool away. Alright, this is as good as it's gonna get. So now, the car bomb. Dr. Dre. Alright. Now everything's sitting where it's supposed to be, pretty much. Now when we turn this over, I grab our rotary encoder board. I stick that on there. Thusly. Yeah, now everything is sitting where it's supposed to. See, now this circuit board is sitting on the flats and everything. Yeah, this looks good. So let's get our screws here. And our screwdriver. I fix it. You break it, I fix it. It's pretty much been the motto of my life. I should have come up with that instead. Because that's what everybody does. They break it, I fix it. It actually sits where it's supposed to. So there's the DC jack, the power switch, right? Let's before we get too crazy here, let's find that brick. Okay, well at least we know it still works. See, off. DSO Shell. Oh. Triggered, I'm triggered. My scope is triggered, everybody. Alright. So, let's get this back in there. Alright, so next step is to solder the board in. That's what it said to do. Now that we got everything looking good, we'll I'll get in here. Okay. I think we can move on to the next step, which was not that sheet, this sheet. And it says, okay, make sure it's even. Step 4. Oh, it says check voltages, but always remove power before disconnecting. Okay, okay. Oh, okay, so what they want us to do is they want us to plug the analog board into the scope, and then we want to go to these test points and make some observations here. I need to make sure that everything's working the way it's supposed to. So you can see we've got our analog board with the header, right? And then we have our other header here. Okay, apply 9 volts. Set the couple switch to ground. That's this, the coupling output. So we're basically shorting the output of the measurement. .22, everybody. So we're pretty good. That's close enough. And so that's the supply power, right? And then V plus, and it shows a little asterisk. What do little asterisks mean? Oh, input dependent. V plus, 8.35. Plus. So that's over here somewhere. Ah. Spooky. Alright. So V plus is right here. .43. Okay. 8.43. This is 8.35, but it does say input dependent. AV plus. Okay, so go to ground here. See that? And then AV plus. We have 4.95. Okay, plus or minus 2%, so we're good. V minus should be minus 7.86. Minus 7.85. All right. AV minus is 5 volts. So here's AV. AV minus. Minus 5.06. Pretty close. V1 should be 0. Which it is. V2 should be 0. Oh, it doesn't like me touching that. 0. Do you see that? Look at that little red LED there. Can you see that? I can't see it. Yeah, see? Only when I touch it. It's like the resistance of the meter is setting it off. V3. V3. Over here. That one does too. Or like 0.004. And V4 should be approximately 1.65 volts. 1.63 volts. Okay. So, looks like we've made them happy. Okay. And check all voltages. Okay. Adjusting trimmers and C5, C3 and C5. Okay. All right, everybody, hang on a second. I'll be right back. Step 5, calibration. Connect the red clip to the test signal terminal and leave the black clip unconnected. Oh, so yeah, we still gotta look at this test clip, which it looks like it goes from the other side here. All right, let's get this test clip on. This guy, ooh, man, you gotta have callous skin like me, then you won't feel it too much. Okay, just be careful, you know. You heat this up. This is all metal, right? So it'll get pretty warm pretty quick, pretty varm. All right, so good to go. Slap our analog board back on. Okay. Now we will hook up our cable which is right here. Okay, plug in our cable. Like so. And then, what does it say? It says, connect the red clip test signal terminal and leave the black clip unconnected. Well, yeah, because everywhere else is ground. So we're gonna clip that on there, right? Okay. And then, where are my, the potentiometers are here. See, here and down there, the green things. So I guess we're gonna set this here. All right, let's turn it on. Okay. And so it's not going to do anything because we have the inputs off. We're going to go to DC. So there we go. Oh, look at that, everybody. You can see, yeah, so that's just like a 1 kilohertz sine wave, right? Let's see, can I? Oh yeah, it's just the time base. My question is, why can't I adjust the wheel? Huh. Adjust, only adjust up, yeah. See troubleshooting guide and forum. Your board might need activation with ID and 8-letter sticker. What the? Ah, great. Well, that's kind of crummy. Hey everybody, Iceman50. So, you know, we put the whole little scope together, and the one thing that I discovered was, you can see my carnage left, I still gotta clean it. So I started crawling through the forums and everything, you know, and there's some people with some similar issues, and one person said, oh, I made sure that my rotary encoder was on the right way, and then that got me thinking. You see here, there's like a silk screen and this, and it says, note, please pay attention to the orientation of the PCB. Use the side with outline marking. Well, it's not really descriptive, so when I put it on there, you can see here's the, I guess, you know, there was 2 sides, and I put the rotary encoder on this side where it says JYE Tech. Well, it's supposed to be on this side. So we're gonna put this back in, and we're gonna see what happens. I gotta clean off the main board here. We gotta clean this off, and then we'll be right back. Hopefully, I still did, you know, send them an email about an activation code. You know, maybe it unlocks certain features or something. I don't know, but yeah, with that encoder being all backwards, it wasn't liking it. So, all right, we'll be right back. I'll see you in a minute. Hey everybody, Iceman50 here. I'm just gonna throw this on the end of the video. I went ahead and for one last time opened this up, and I added in a battery and a 9-volt step-up board. One of these, remember I showed you. So battery gets soldered in here, and then you get an output over here and here. So I ran the output to the little connector on the board. I actually had some connectors, some silicone wire that I used for my my REM puck. So I just took one of those, soldered it to the board here, and then soldered the battery. I did find the battery that I bought for this, and I just kind of like, this is kind of like sitting, whoa, it's kind of like sitting under the board over here somewhere. I haven't, there's not a lot of room. The battery's pretty big. It takes up like most of the space, and then I just found a way for it to kind of all sit in there without touching anything. So let me show you here. We'll turn it on. DSO Shell. Right. And it works pretty good with the adjustments now. So like if I here, let me zoom you up and zoom you in. Okay, so I can attach my probe, which, like I said, I do have some regular actual 10-to-1 probe that you can use. But so on the top here, you got this. This is your 1 kilohertz square wave test pattern. So you just clip this on here, and you can see we got our test pattern. It looks pretty good. And then you can see now, see how seconds per division is highlighted? If I click that button and then move the knob, you see it's weird. It goes to the right, goes down, but to the left goes up. But you can see if this is after I flip the encoder board around and everything. You see it's working just fine. And you can turn that off. You can change your volts per division over here. If you click that, you see how it highlights, and then you can move the knob. So you can move it bigger, smaller, right? Okay, and you click it again and it turns off. There's some cool things you can do, like if you push OK for 3 seconds, it pops up all the data, and then it automatically holds it. So you can see our frequency is 1 kilohertz. Cycle is basically 1 millisecond. Our duty cycle, you can see, right? Our voltage max, min, that's pretty cool. So if you just push that once, now it's running, and you can run it with the data so you can see it real time. And then you push and hold again, it goes away, it holds, and then you just push to unhold. So yeah, you can see that it turned out pretty good. And what I like now is that it's battery powered. So, you know, the only downside for right now is that, you know, since I don't have a spot for it to come out, I'm just gonna have to take out the 4 screws and charge it up when I want to. But when it's time for that, I will make a hole so that I can just plug in a micro USB. I'll bring that board over here. I'll do something. So, but yeah, pretty nice little product. I can't wait to get the the 2-channel version of this scope. I really like this JYE Tech's product line. So anyways, yeah, thanks for watching and suffering through this. And we'll see you guys on the next one. I think I got to keep working on this 3D printer. So we'll see you on the next one. All right, easy.